Okay, so let us start today's physics session. So, in the last two or three lectures, we have covered the module 1 or chapter 1 of the 12th physics, that is the rotational dynamics. So, today we will start with the second topic, which is the mechanical properties of the fluid. So, in the mechanical properties of the fluid, we have four important sections. The first is the fluid static. So basically, we will deal with the some properties or the equations when the fluid is in rest condition. So which is called as a fluid static. So in the fluid static, we have the states of matter, so solid, liquid, and gases. Then some properties of the fluid, so properties of the ideal fluid. Then we have the equation for the pressure on the fluid and the Pascal law. And next we have the pressure measurement devices. So we have two devices. One is the mercury barometer and second is the U2 manometer. Okay. So this is about the fluid static. Second important concept in the chapter 2, it is the surface tension. So in the surface tension, we will discuss the surface energy, then angle of contact. So in the surface energy, we have the equation for the surface tension. Then we have the shape of meniscus. So how the concave meniscus is formed, how the convex meniscus is formed. Then shape of the liquid drop on the solid surface. Next we have the capillary action. Okay, so for capillary action we have the equation for the rise of the liquid in the capillary tube. So there is the equation of H. And the last point in the mechanical properties of the fluid, it is about the fluid in motion. Okay. So in that we will study different flow visualization methods. So in that we have flow line, streamline, flow tube. Then difference between the laminar flow and the turbulent flow. Then we have the equation for the critical velocity and the Reynolds number. Then we will discuss the property which is the viscosity, and there is one equation which is called as a Newton's law of viscosity. After that, we will discuss the Stokes law, so equation of the Stokes law, then the continuity equation, Bernoulli's equation, and application of Bernoulli's equation for some flow measurement devices like venturimeter, and last is the speed of the efflux. Okay. So very basic concept about the fluid. So fluid basically it is the substance that can flow. So it can exist in liquid or the gaseous form. Even the plasma is considered as a fluid. Okay. So the technical definition of the fluid is fluids are substance which cannot resist any shear force applied on it. So for the fluid, this is the important point. The shear modulus it is zero for the fluid. Okay, so there can be a straightforward question. The shear modulus for the fluid, so it will be a zero. So what are the properties of the ideal fluid? So ideal fluid basically it is incompressible, so we cannot compress the fluid. So as it is incompressible, the density it remain constant. Okay, so there is no change in the density. The flow is irrotational. There is no rotational effect in the flow. Ideal fluid is considered as a inviscid. The meaning of inviscid is the viscosity for the ideal fluid it is zero. Then flow is steady. The meaning of steady flow is there is no change in the properties of the flow with respect to time. So if there is a velocity as a one parameter, then the change in the velocity with respect to time for the ideal fluid it will be a zero. Okay. Then ideal fluid do not offer any shear resistance as they do not have the viscosity. So shear stress is zero for case of ideal fluid, and the ideal fluid can be subjected only to the normal stresses or the compressive stresses. Okay, so this compressive stress is called as a pressure. Okay, so these are some properties of the ideal fluid. So the point to be noted is density is constant for the ideal fluid. then viscosity is 0. Rate of change of velocity or any other parameter, it is 0. So flow is steady. It doesn't offer any shear resistance as it doesn't have the viscosity. Okay, and it has only the normal compressive stresses, that is called as a pressure. Now when the fluid is at rest, we can measure the pressure by this formula. P is equal to force per unit area, and the unit is, if force is in Newton and area is taken as a meter square, so it is Newton per meter square. Okay, and the dimension for the pressure, it is L minus 1, M1 and T minus 2. Sometimes pressure will be given in terms of bar. So this is the relation between bar and the Pascal. So 1 bar pressure, this is equal to 10 to the power 5 Newton per meter square, and 1 Newton per meter square, this is equal to 1 Pascal. Okay, so you should know this relation. So 1 Newton per meter square is nothing but 1 Pascal, and 1 bar is equal to 10 to the power 5 Newton per meter square, or this is equal to 10 to the power 5 Pascal. Okay, so this is the conversion of bar into Pascal. Now if the fluid is at rest, we can determine the pressure exerted by that fluid at any point. So basically the pressure in the static fluid, it depends on its density, then the height of the liquid above that point, and the acceleration due to gravity. Okay, you can consider one simple example. There is one tank which is completely filled with the water. Okay, and if you want to find out pressure at the bottommost point, so let us take the height of the liquid in the tank, it is h. Okay, and we want to find out the pressure exactly at point A, which is the lowest point. Then we can write the equation: pressure at the point A, this is equal to density of the liquid, acceleration due to gravity, into height of the liquid above that point. So it is Pa is equal to rho gh, and unit will be Newton per meter square. Then there is a next concept is about the absolute pressure and the gauge pressure. Okay, the meaning of absolute pressure is when we measure the pressure by considering the effect of atmospheric pressure, then that is called as the absolute pressure. Now consider this same example. This is the tank, it is completely filled with the water, and this is the point where we want to measure the pressure. So let us take the point is A. Okay, and the height of the liquid above that point, so that height is h. So if you want to find out the pressure at point A, we can write the equation: Pa is equal to just rho gh. Okay, but this pressure that we are writing as a rho gh, it is without considering the atmospheric pressure. Okay, so if you consider the topmost layer of the liquid, this topmost layer is experiencing the pressure due to the air. Okay, that is called as atmospheric pressure. So this pressure, this is denoted as a P naught. Okay, so if I consider this pressure P naught and the pressure because of the liquid height, then we have to write the total equation: Pa is equal to P naught plus rho gh. Okay, so this is the net pressure acting at point A. This pressure, which is with consideration of atmospheric pressure, this is called as a absolute pressure. And if you do not consider the atmospheric pressure, and if I just write the value as a rho gh, so this is called as a gauge pressure. Okay, so gauge pressure means if we consider only the liquid height, and if you do not consider the atmospheric pressure, that will be treated as a gauge pressure. So it is atmospheric pressure minus, sorry, absolute pressure minus atmospheric pressure, that is nothing but the gauge pressure. So gauge pressure is the difference of absolute and the atmospheric pressure. So absolute pressure is the total pressure. So atmospheric, that is a P naught plus rho gh. Okay, so you should remember these two equation: one for the absolute pressure, which is the total pressure, and the gauge pressure without considering the atmospheric pressure. So it is atmospheric absolute pressure minus atmospheric pressure. Then there is one concept of hydrostatic paradox. Okay, the meaning of hydrostatic paradox is, if we consider different containers or different vessels filled with the liquid, okay, the shape is different, and in all the container the liquid level is same. So that level of the liquid, it is H. Okay, and if you want to find out the pressure at the bottommost point for each vessel, so consider this pressure as a PA, this pressure is a PB, this is PC, and this is a PD. Okay, so irrespective of the shape of that container or shape of the vessel, okay, pressure at one layer, so this is one layer, okay, so this pressure will remain same. So here PA, this is equal to PB, this is equal to PC, and this is equal to PD. Okay, so this pressure will only depend on the height H. It will not depend upon the shape of the vessel. Okay, this is called as a hydrostatic paradox. So the basic equation for all this pressure, this is P is equal to rho G into H. So this is called as a hydrostatic equation or the hydrostatic law. Next concept we have is about the Pascal law. So Pascal law, the pressure applied at any point of an enclosed fluid at rest is transmitted to every point of the fluid and on the wall of the container. Okay, so this concept of Pascal law, it is used in the design of the hydraulic lift, hydraulic brake, then hydraulic jack. So the concept is, you can consider, this is simple schematic diagram for the hydraulic lift. So this consists, so this is the cylinder. So this cylinder is connected to another cylinder, okay, having different cross section. This is the piston of the small cylinder, and we are applying the force F1, okay, on this small cylinder. This force F1 will create the pressure on the fluid, okay, which is enclosed in the complete vessel. Okay, the same pressure will get transmitted on the other side. So this pressure is same for both the piston. Okay, and here the force amount, it will get amplified. Okay, so if you use the equation for pressure, we have the equation pressure is equal to force upon area. Okay, for the smaller cylinder or the smaller piston, this pressure P1, this will be F1 upon A1. Okay, for larger piston, P2 is equal to F2 upon A2. Here pressure P1 and the P2 will remain same. So P1 is equal to P2, this is equal to P. Okay, so we can write the equation F1 upon A1 is equal to F2 upon A2. So with this equation we can determine how much force is amplified on other side. So this is the basic equation for the Pascal law. F1 upon A1 is equal to F2 upon A2. Then the next concept we have is about the mercury barometer. So basically mercury barometer, it is used to measure the atmospheric pressure. Okay, so it is just an inverted glass tube, and the fluid used is the mercury. Okay, so just by measuring the height of the mercury rise in the tube, that is the edge height, we can determine what is the atmospheric pressure. Okay, so here atmospheric pressure, this is basically a P naught. Okay, so P naught, this value This is given as the hydrostatic equation. This is a rho g into h. Okay. So just we have to consider the rho as a density of the mercury. Okay. So this value will be 13,600 kg per meter cube. Okay. G will be the acceleration due to gravity, and here h is the height of the mercury in the tube. So with this equation, we can measure the what is the atmospheric pressure. Second instrument which is used to measure the pressure in the pipe. So this is called as a U-tube manometer. Okay. So basically, it consists one U-tube. Okay, and this U-tube has one liquid. So this liquid is called as manometric fluid. So general this manometric fluid, this is taken as a mercury. Okay, so because it is the heaviest fluid, and with this mercury we can determine what is the pressure inside the pipe. So in a three dimension, so this is the pipe, and there must be a fluid which passes through the pipe. This fluid, if it has a pressure suppose A, okay, so we can measure this pressure by connecting a glass tube like this. And this glass tube, it consists one heavier fluid. So generally that heavier fluid, it is taken as a mercury. Okay, so whatever the pressure inside the pipe, it will get equally transmitted on the one side of the glass tube. Okay, and because of this pressure we can see there is a level difference. So this level difference we have to measure. So if you measure this level difference as a h, then as per the hydrostatic law, pressure in one layer of the fluid, it will remain same. So whatever the pressure at this point, so consider this pressure as a PA. So this is the pressure in the pipe. At this point pressure will remain same, so that pressure has to be A. Okay, and pressure at point A we can measure in terms of this height h. So if you write the equation PA, this is equal to density of the fluid. So right now it is a mercury, G into H. Okay, so this is the pressure. This pressure will be a gauge pressure, and if you want to find out the total pressure, that is the absolute pressure, so PA will be, we have to consider the atmospheric pressure. So there is atmospheric pressure, so this is a P naught. So just we have to add the atmospheric pressure P naught. So P naught plus rho GH. Okay. So with this equation, we can determine what is the pressure inside the pipe. Okay. Now let us discuss some MCQs which are based on the pressure and the Pascal law. Okay, refer the first question. The pressure at the bottom of a liquid tank is not proportional to acceleration, density, height, and area of the liquid surface. Okay, so exactly इथे क्वेश्चन मध्ये काय सांगितलं आहे की प्रेशर ॲट द बॉटम ऑफ लिक्विड टँक इज नॉट प्रोपोर्शनल, कशावरती प्रोपोर्शनल नाही. ओके, सो वी शुड नो द बेसिक इक्वेशन. सो P is equal to rho G and H. Okay, so here pressure is proportional to density, pressure is proportional to acceleration due to gravity, and pressure is proportional to height. Okay, सो ऑप्शन ए ह्यावरती प्रपोर्शनल आहे, सो हा पण नाही आहे. डेन्सिटीवरती प्रपोर्शनल आहे आणि हाईटवरती प्रपोर्शनल आहे. ओके, प्रेशर हा त्याच्या एरियावरती, लिक्विड सरफेसचा जो एरिया आहे त्यावरती डिपेंड नाही. ओके, सो द करेक्ट ऑप्शन हिअर इज द ऑप्शन डी. ओके, सो प्रेशर इज नॉट proportional to the area. Okay, so option is option D. Okay, refer the second question. So the question is, a tank with the length 10 meter, breadth 8 meter, and the depth 6 meter. It is filled with the water of the density 1000 kg per meter cube up to the top. The thrust on the bottom of the tank is, so basically thrust means it is the force exerted by the water on the bottom of the tank. So we have to find out what is the value of force. Okay, so just we can imagine the given question with this diagram. So there is one tank like this, and this tank is completely filled. So it has a dimension, the length is 10 meter, so this is a 10 meter, its a breadth is 8 meter, and its a height is 6 meter. Okay, so initially it is completely filled. At the bottom surface of the tank, so this is the bottom surface, what is the pressure, what is the force exerted? So what is the value of force? Okay, so to find out the force, we have the equation. We can use the equation P is equal to rho gh. Okay, so this is the pressure at the bottommost point. If I select any point, we can determine its pressure as rho gh. Okay, so we know the height h, so we can write this as rho is the density, so this is 1000 for the water, so it is given in the problem. G is the acceleration due to gravity, so this is a 9.81, and the height h, so height of the liquid above the bottom surface, it is a 6 meter, so here 6. Okay, and this pressure we can write as force per unit area. Okay, so we want force value, so we can write here force is equal to this 1000 into this is 9.81 into 6 into, just take this area on the right side, so area will be is 10 into 8, so this is the surface area at the bottommost point, so this is 10 into 8. Okay, now just simplify this equation, so this 10 into 8, this will be 80. Okay, now this 80 into 6, so this is 480 x, so here 8 6 are 48 into 10, this will be 480. Now for sake of simplicity, just 9.81 approximate value is 10. Okay, so this will be 10 into 10, 10 into 1000, so this is a 10,000. Okay, now just write this in a 10 to the power, so we will get this as, this is 10 to the power 4 into, this value is 4.8 into 10 to the power 2. Okay, so finally we will get the value as 4.8 into 10 to the power 4 plus 2, so this is 10 to the power 6. Okay, so this is the value of force, and unit will be Newton. Okay, so just check the answer which is near to the final answer. So if you refer, the correct answer is 4.7 10 to the power 6. Okay, if you refer the remaining option, this is 10 to the power 4, this is not the correct answer, this is 10 to the power 5, this is 10 to the power 7. Okay, so correct option is option B. So to solve such type of problem, we have to refer the basic equation, pressure is equal to rho gh. This equation is the hydrostatic equation or the hydrostatic law. Okay, next equation, if you want to find out the force on any layer, then force per unit area. Okay, and from this we can determine the force value. Okay, now refer the third question. So what is given in the question? In a hydraulic press, small f and capital F are the forces acting on the small piston and the large piston having the diameter small d and the capital D. Then what is the ratio? F upon capital F. Okay. So we have to find out this ratio small f to the capital F. Okay. So the hydraulic press, we should know the basic diagram or the schematic diagram. So this is the representation for the hydraulic press. Okay. So basically it consists two cylinders, one smaller cylinder and one larger cylinder, and it has a piston. So this is the piston. The force applied on the smaller piston, so this will be small f, okay, and it has a diameter small d for this piston. The force on the larger piston will be capital F, and its diameter is a capital D. Okay. So as per the Pascal law, we know that the pressure will remain same. So pressure on both the sides is same. So we can write P. Let us assume this as a P1 and this is a P2. So P1 is equal to P2. So P1 we can write as force per unit area. So area of the smaller piston is pi by 4 small d square. This is equal to force on the larger piston, it is a capital F divided by pi by 4 capital D square. Okay. So if you simplify this, we can write the ratio as small f to the capital F. This is equal to D square upon D square. Okay. So the equation that we have used, it is the force pressure is equal to force per unit area, and pressure is same on both the sides. So this is the Pascal law. Okay. Now if you refer the option, the correct option is option C. Sorry, this is small d. So if you shift this small d, it will be in the numerator and capital D will be in the denominator. So small d upon capital D square. So option is option C. Okay, now refer the next question. So this question is again on the Pascal law. So the question is the ratio of area of cross section of two piston in a hydraulic machine is 1:15. Okay, so ratio of cross section is given. Find the force that should be applied on the narrow piston to overcome a force of 120 Newton on the bigger piston. Okay. So again refer the schematic diagram. So this is the smaller piston. On the smaller piston, you can assume this force as a small f. This is the bigger piston. On this, assume the force as a capital F. Okay. This has a area small a. This has a area capital A. Okay. And pressure is same. So pressure gets equally transmitted on both the side. So we can write the equation P1, this is equal to P2. So P1 is force upon area. On bigger piston, force is F divided by capital A. So if I write the ratio, so ratio given here is of smaller piston to the larger piston. Okay. So write the ratio as A upon capital A. So this will be equal to small f upon capital F. Okay. So A upon A, this value is given. So this ratio A upon A, this is equal to 1 upon 50. 1:15 means 1 upon 15. So just write here 1 upon 15. This is equal to small f upon capital F. Okay. Now the force on the bigger piston is given. This is equal to 120 Newton. So 1 upon 15, this is equal to small f divided by 120. So from this we can write 120 upon 15, this is equal to small f. So 15 at this will be 120. So small f is equal to 8 Newton. Okay. So force on the narrow piston that should be applied, that force is equal to 8 Newton. So if you refer the option, the correct option is option D. Okay, so on the Pascal law or on the pressure equation, you can expect such type of problem. Okay. Now the next concept is the surface tension. So surface tension means the tangential force acting per unit length on both the side of an imaginary line which is drawn on the free surface of the liquid. Okay. So mathematically, we can write surface tension is equal to force upon the length. So the unit is Newton per meter, and its a dimension is, this is L0, M1 and T minus 2. Okay. So surface tension, it is the reason due to which the insect or the needle, it can float freely on the surface of the water. Okay. Now what are the reasons of the surface tension? So the reason is the intermolecular force. So the cohesive forces, and second is the adhesive force. So the cohesive force is attraction between the molecules of the same substances. Okay. So this force is strong in a solid and it is a weak in the liquid and gases. So because of the cohesive forces, the solid have the definite shape. Okay. And liquid droplets coalesce into one drop due to the cohesive forces. The next force is the adhesive force. So it is a force of attraction between the different molecules. So molecules of the different substance. And because of the adhesive forces, water droplet sticks to the glass surface. And if you refer the surface tension in the mercury, it is always greater than the water, and water is greater than the glycerin. Okay. And these are some exact values: 0.43, 0.072 and 0.063. Now the second concept which is depending on the surface tension, it is the surface energy. So basically it is the work done on stretching the surface film by an amount dA. Okay, so this work done is stored as a potential energy, and this potential energy is referred as a surface energy. So mathematically we can write surface energy as W is equal to the surface tension into the change in the area. Okay, in a simple form we can write this: W is equal to T into area. Okay. So there can be a question on the surface energy. So you should remember this formula: W is equal to T into D. And sometimes surface tension is also called as surface energy per unit area. Okay, now these are some standard formulae to required to solve the problem on the surface tension or the surface energy. So the first formula is the basic formula of the surface tension. So surface tension, this is equal to W upon dA, or W is equal to T into dA. Okay. And surface tension also we can write T is equal to, this is F upon L. So this is Newton per meter. Next formula is the work done in forming a liquid drop of radius r and the surface tension T. So when there is a liquid drop, then the surface energy or the work done will be W is equal to, so it is area into the surface tension. So area of the liquid drop, this will be always 4 pi r square into the surface tension is T. Okay, so this is the surface energy for the liquid drop. So work done in the increasing the radius of the liquid drop from R1 to R2. So suppose we have initial drop having the radius R1 and we want to increase the radius. So it is the R2. So what is the work done? So here work done will be the change in the area. So it is a dA. So that change in the area will be surface area will be 4 pi r square. So R2 square minus R1 square into the surface tension T. Okay. So this is the work done when we change the radius from R1 to R2 for the liquid drop. Similar expression we can write for the soap bubble. So only difference between the bubble and the drop is, in case of drop we just have one surface area, and for the bubble, so for the soap bubble we have to consider the inner area and the outer area. So this is the soap film in the soap bubble. So we have to consider this area as well as the outer area. Okay. So we can refer here work done in the forming the soap bubble of radius r and having the surface tension T. So that work done, this is always equal to, we have two areas. So 2 into surface area will be same 4 pi r square. Suppose r is the radius. Okay. Into the surface tension is T. Okay. So this is the work done or the surface energy for the soap bubble having the radius r. Now, if you want to increase the radius from R1 to R2, then we will have the work done W is equal to 2 into 4 pi into R2 square minus R1 square into the surface tension T. Okay. So next we have two equation. The first equation is work done to split a liquid drop of radius capital R into n number of smaller droplet having the equal radius. Okay. So that work done, it can be given with the equation W is equal to 4 pi r square into surface tension into bracket n raised to 1 by 3 minus 1. Okay. Where n is the number of smaller droplet. So its meaning is if you have one bigger drop, it has a radius capital R, and if this bigger drop forms number of smaller droplet like this. Okay, suppose the droplet is n in number and all the droplets are equal in size, so all have same radius, that is the smaller. Okay, so the work done in forming n number of droplet, it can be given by this equation. Now exactly reverse, work done to form a bigger drop by n identical smaller droplet. So we have n number of smaller droplet, and if you want to form one bigger drop having the radius capital R, then this work done will be 4 pi r square capital T in bracket n minus n raised to 2 by 3. Okay. So you should remember all this formula to solve the problem on the liquid droplets or the soap bubble. Okay, now just refer the first problem, which is on the surface tension. So the question given here is a beaker of radius r, which is 10 centimeter, is completely filled with the water. Calculate the force of surface tension on any diametrical line on its surface if the surface tension of the water is 0.075. Okay. So in the question, what is given? There is one beaker like this, and this beaker, it is completely filled with the water. So this is completely water. And we want to find out what is the surface tension on one diametrical line. Sorry, force because of surface tension. So consider this is the diametrical line on the surface of the water. Okay, so there will be surface tension acting on this line like this. So this is a T. Okay, so we can write the equation T is equal to force per unit length. Okay, so T is given, this value is 0.075. We are interested in the force value, so we have to find out what is the force divided by length. So length will nothing but the diameter. Okay, so here radius is given, this is 10 centimeter, so length will be 2 into r. Okay, so from this we can find out the force value. So F is equal to 2 into radius is 10 centimeter, so the answer will be, centimeter will be in meter, 10 into 10 to the power minus 2, okay, meter, into 0.075. Okay, and just simplify this equation, so we will get the answer as 10 into 10 to the power of minus 2, so this will be 10 to the power minus 1, okay, into 0.075 we can write as 7.5 into 10 to the power minus 2. Okay, so from this 7.5 into 2, this will be 15 into 10 to the power minus 3. Okay, so this is the force, this is in Newton, or if you write this in a decimal form, 15 into 10 to the power minus 3, it means 0.015 Newton. Okay, so this is the answer. So the formula that we are using, it is the basic formula, surface tension is equal to force upon length. Okay, so these are some theoretical questions. The first question is, the small drop of liquid acquires a spherical shape because of, okay. So of first option is of the gravitational force acting on the drop. This is not the option. Because of atmospheric pressure, this is also not the option. Volume of spherical drop is minimum. Okay, so this is the correct option. Second question is, the surface tension of liquid is due to. So surface tension of liquid is due to the cohesive forces. So it is a force of attraction between the same substance or the same molecules. Third is a brush deep in the water and it is removed. Okay, so the hair of the brush clinch together due to the force of attraction between the hairs, the characteristic property of the hair, viscosity of the water, or the surface tension of the water. Okay, so it is because of the surface tension. Okay, next question is, at a critical temperature, the surface tension of the liquid is. So always remember, at the critical temperature, the surface tension of the liquid, it is a 0. Okay, refer the next problem. The surface tension of the liquid, it is given as 10 raised to 8 dyne per centimeter. This 10 raised to 8 dyne per centimeter, it is equivalent to. So basically, here we want to convert dyne per centimeter into MKS unit, that is a Newton per meter. So first note down the given value. Here surface tension. So T is equal to 10 raised to 8. This is dyne per centimeter. Okay. To solve this problem, we should know the relation between dyne and Newton. So 1 dyne or 1 Newton, this is equal to 10 raised to 5 dyne. or 1 dyne, this is equal to 10 to the power minus 5 Newton. Okay, so you can put this value in this equation. So 10 raised to 8 into 10 to the power minus 5, so this will be converted in Newton, divided by, so there is a centimeter, so the conversion is 1 centimeter, this is equal to 10 to the power minus 2 meter. Okay, so just multiply here by 10 to the power minus 2, so this will be in meter, so final unit will be Newton per meter. Okay, now simplify this equation. So you will get 10 raised to 8 into 10 to the power minus 5 upon 10 to the power minus 2. So here 10 to the power minus 2 and minus 5. So the remaining value is 10 to the power minus 3. Okay. And here 10 to the power 8 plus 10 to the power minus 3. So 8 plus minus 3, 5. So you will get 10 to the power 5 Newton per meter. Okay. So the correct option is option C. Okay, refer the next question. This is on the surface tension. So the question is, there is a needle of 0.05 meter. So this is the length of the needle, can just rest on the horizontal surface of the water without wetting. Okay, what is its weight? So the diagram will be, so this is the free surface of the water. So this can be a container, it is completely filled with the water. Okay, and there is a needle which is floating freely. So this is the needle. Okay, it has a length L. So as it is freely floating, it means the surface of the needle will experience a surface tension, force because of the surface tension, like this. Okay, and this force basically it will support the weight of the needle. So the formula we can write, so the surface tension T, this is equal to the force upon the total length. Now if you consider the needle, then you can observe here it will have the two contact layers. The one contact layer is this, and this is the second contact layer. Okay, so this contact layer has a length L and this has a length L. So total length in the contact with the liquid or the water will be, so F upon the 2L. Okay, and this length or the force acting on this length, it will support the weight. Okay, so the force is nothing but the weight. So this is W divided by 2L. So from this we can write W is equal to surface tension into 2L. So T is equal to, sorry, T is given in the problem. So this is 7 into 10 to the power minus 2. So this is 7 10 to the power minus 2 into total length is 2 and length is given. So needle is 0.5 meter. Okay. Now just simplify this equation. So this is 7 into 10 to the power minus 2 into 2 into, I will write this 0.05 as 5 into 10 to the power minus 2. Okay, so this 5 into 2, this will be 10. Okay, so 10 10 to the power minus 2 and minus 2. Okay, so this is minus 4 plus 1, so minus 3. So 7 into 10 to the power minus 3. Okay, if you write this in a decimal, this will be 0.0007 Newton. So this is the weight of the needle which is supported by the surface tension. Okay, so if you refer the option, the correct option is option C. Okay, so when there is a problem on the needle floating on the liquid surface. So we should know the basic formula. T is equal to force upon length. Only in case of needle, take the length as a 2 into L. Okay, because two layers of the needle will be in contact with the liquid. And here force, this force is nothing but the weight of the needle, which is supported due to the surface tension of the liquid. Okay. Okay, refer the next problem. It is again on the surface tension. So what is given here? A thin circular plate of radius r has a hole of radius r at its center. The plate float at the surface of the liquid having the surface tension capital T. The force of the surface tension acting on the plate. Okay, so basically we have to find out the equation for force due to surface tension on the given plate. Okay, so the shape of the plate will be like this. The plate is basically a circular. Okay, and it has a center hole like this. Okay, so this radius is a small r, this radius is a capital R. Okay, and this plate, this may be floating on liquid surface. So let us assume this is a tank and this is the liquid. Okay, so this will be subjected to the surface tension. Okay, so if you refer this plate, it has a two contact layers. One layer is the inner layer and second layer is the outer layer. Okay, so when we write the formula, surface tension, this is equal to force upon length. Okay, so we have to consider the total length. So this total length, this is equal to force upon the length for the inner layer. Okay, so this length is equal to the circumference of this circle. So that circumference is 2 pi r plus this length. Okay, so this is circumference 2 pi into capital R. So this will be F upon 2 pi in bracket R plus capital R. Okay, now this is the surface tension. So from this, if I write F, this is equal to 2 pi into surface tension T in bracket R plus R. Okay, so if you refer this answer, then correct option is option C. This is 2 pi into capital T in bracket R plus R. Okay, so this is a force due to surface tension acting on the circular plate having the center hole. Okay, so the basic formula is T is equal to F upon L. Okay, the remaining part we will discuss in the next lecture. So you can solve this problem. You can just take the screenshot and try to solve these two problems. The next lecture will start at 11:45. So it is the chemistry lecture. Okay, so join the same link at 11:45.